Hi, in this video, I'm going to introduce VPNs, virtual private networks. So just like it says, a VPN is a private network. It's created by tunneling over a public network, typically the internet. It's usually an alternative to using like a leased line or some other type of private circuit. So VPNs allow us to actually treat a public infrastructure like the internet as a private circuit. And we'll actually see how this is done in a later video with GRE as far as the tunneling is done. But VPNs, typically we want a secure implementation, so we use encryption like IPsec. And these are called IPsec VPNs. To do a VPN itself doesn't necessarily mean you're going to do encryption, but that's usually what we want the VPN for, is to encrypt the data between the two endpoints. To implement the VPN, we're going to need a VPN gateway. This could be a router, a firewall, or a ASA, Cisco Adaptive Security Appliance, or many other things as well. And we'll take a look at the different parts of this in a moment. So why would you want to do a VPN? Well, first of all, what is the alternative? So you could just have a use the public internet and access. But if we want security, if we want encryption, then we're typically looking at something like a VPN, or have a leased line, a private circuit of some sort. But the benefit of the VPN is the cost savings, being able to use the public internet to send our traffic instead of having to pay for a private circuit like a leased line is a lot more cost effective. And we can use existing technologies such as DSL and cable modem or whatever, however we're accessing the internet now. So there's definitely a cost saving. Scalability too. Being able to use the internet as like a multi-access cloud, so we don't have to purchase multiple leased lines is both cost effective and scalable. And like I mentioned, the compatibility with existing broadband technologies. So we'll see this in a moment, but you can do this quite easily using your home or mobile device and set up a VPN connection to the VPN gateway. And usually we want some sort of security, and this is where we use things like encryption and authentication protocols like IPsec. Okay, site-to-site VPN. So there's two types of VPNs. Site-to-site VPNs is when we connect entire networks to each other. So over on the left here, we have one network here, and over on the right, a totally different network. The site-to-site VPNs means that we have pre-configured both VPN terminating devices, one at each end, so that's all pre-configured. So anything that is sent from this network here that needs to go to this network, of course, we could just be going to Amazon or Facebook here, but if it's going to go to this network over here, it's going to go through the VPN tunnel. And it looks like we're using encryption and all kinds of good stuff here. So it shows the CLA. I'm showing a sample CLI configuration here on some routers like the RV320, or maybe even your home router. You might have a GUI that does this VPN tunnel for you. Okay, so the end hosts basically send and receive just TCP/IP traffic as normal. Everything goes through the gateway, and the VPN gateway is responsible for doing the tunneling, the encapsulation, which is the encapsulation, and also any security, the encryption, authentication, and all that good stuff. All handled transparent from the user. Remote access VPNs. So this is something I use on my connections to various places. Sometimes I actually do use Cisco AnyConnect as my security, as my VPN appliance software. When connecting to Cabrio's web server, I have to VPN into that part of the network, or when I'm doing some work for Cisco or Cisco Press. So I use different, same VPN software, just different ways to connect, different VPN tunnels I connect to different VPN terminating devices, whether it's Cabrio, Cisco Press, or something else. So basically, it's just used to connect individual hosts that need to securely access a remote network. Okay. The VPN software can be installed on your desktop, your mobile device, your laptop, or whatever it might be. There's something also known as DMVPN, Dynamic Multipoint VPN. Basically, what this does is instead of having a hub, just having everything go through the hub, it actually can dynamically set up and tear down connections between the different spokes. So here's our hub, and then if you remember in things like frame relay or things like this, where you would actually be paying for virtual circuits, and you want to reduce that cost, you'd have a hub and everybody connects to the hub. We call these spokes that connect to the hub. To go from spoke A to spoke C, that all traffic would have to pass through the hub. What DMVPN does is it builds a secure network that exchanges data between these two sites without having to pass through the hub. And it can do that all dynamically. And the way it does that is use things called next hop resolution protocol. It's a distributed mapping database of public IP addresses for all tunnel spokes. Won't go into the details here, but this is some of the technologies it uses. It uses multi-point GRE, generic routing encapsulation. We'll be talking more about GRE coming up. And also IPsec for encryption. Okay, so that's just a short introduction of VPNs. You'll get a kind of a little bit better idea how this can actually work with the tunneling coming up when we look at GRE.